morning, ladies and gentlemen. This is section 7.3, and now we're going to start doing proofs with our triangle congruence theorems. And so we're going to start right here with example number 1. If M is the midpoint of CD and EF, we want to prove that triangle CME is congruent to triangle DMF. So first of all, I'm going to draw in all my congruency markings from my givens. If M is the midpoint of CD, I know that these two lengths are equal to each other, and I know that M is the midpoint of EF. Thus, these two lengths must be equal to each other. Now, is there anything else in my figure that I could go ahead and draw in that I already can see? Hopefully you notice something about these angles right here. Hopefully you notice that they're congruent because they're vertical angles, right? And that's given to us by the picture, by the figure. So I can tell that these are congruent. Now I'm already thinking, hey, I could use the side angle side theorem, right? So let's see how this goes. If M is the midpoint of CD and EF, that's my given. That's the first thing we always write. And now I want to say MC is congruent to MD. And I'm going to say that because of the definition of a midpoint. Now I can say the angle CME is congruent to angle DMF because of the vertical angle theorem. And now I want to say that ME is congruent to MF because of the definition of a midpoint. And finally, I can say triangle CME is indeed congruent to triangle DMF because of what theorem? Side angle side. All right, let's try another one. Wait, we're going to do, yeah, here we go. So if I am given that AB is congruent to AE and DE is congruent to BD, I want to show that these two triangles are congruent to each other. First of all, I'm going to draw in my congruency markings. If AB is congruent to AE and ED is congruent to BD, I'm going to draw in those symbols. Now, do you notice anything else that the figure gives you? Hopefully you'll notice that they share this side length. Would you agree with that? So that side length has to be equal to itself. Now, what property says something is equal to itself? Think about that for when we write in our proof. All right, so the first thing I'm going to write is AB is congruent to AE, and ED is congruent to BD. And remember, when we use the congruence, we have to use these symbols, right? When they're equal, when they're measures, congruent when they're segments. So that justification is that it's given. And so then I'm almost to the point where I can say they're congruent. I just need to say something about this third side length, agreed? So now I'm going to say, hey, segment AD is congruent to itself. And why do we know something is congruent to itself? The reflexive property. And now, can I indeed say that these two triangles are congruent? Absolutely. What theorem gives that to me? Theorem side, side, side theorem. Beautiful. Usually students find proofs with these triangle congruence theorems to be a little bit easier than the proofs we start off with. So enjoy. If OE is the perpendicular bisector of GB, we want to prove these two triangles are equal to each other. So we're going to start off by drawing in all the information that we know. If OE is the perpendicular bisector, I know that these two segments must be equal, and I know that these two angles must be equal. Would you agree with that? Now, what else is given to me by the figure? What else can I see just by looking at it? Hopefully you notice that they share this side length in here. All right, so now I'm going to start off with my givens. OE is the perpendicular bisector of GB, and that's given. And now I'm going to go ahead and say, hey, GE must be congruent to EB because of the definition of a bisector. And then I'm going to say the angle, measure of angle GEO equals the measure of angle BEO. And that's because they're both right angles. So let's call that, being the definition of, maybe I need to say that they're right angles. Hang on just a second. If I already know they're right angles, I can say they're equal to each other. Sorry, just thinking for a second. Definition of perpendicular. If I need a middle step in here, I'll tell you tomorrow, but I think I'm good on that. Because if they're both, oh, let's add this one point. Good idea. Let's add that they equal 90. They equal each other's because they equal 90. Definition of perpendicular. Done. All right, now I have stated these angles and these side lengths. The last thing I need to say is that OE equals itself. And why can I say that, hey, OE is congruent to OE? That's, again, the reflexive property. Now, I can say my two triangles are congruent. What theorem tells me that? Yeah, you got it? Is it side angle side? Awesome. Side angle side theorem. Okay, for tomorrow. Oh, wait. You know what? Beginning of class, we'll walk through this one together just to get you warmed up. For tomorrow, I'd like you to write down this triangle, write down your givens, and go ahead and try to prove that angle or length AD is congruent to length BDB. Take it as far as you possibly can. Here's your plan of action. First of all, you want to show that this triangle is congruent to this triangle. Then you can use one of your theorems to say your corresponding parts are congruent to each other. So try that on your own. When you come back tomorrow, we'll walk through this base angle converse theorem together. And I will see you then.